We're going to start with talking about functional relationship versus a statistical relationship. And the key word in functional relationship is function right there. All right, so when you see functional relationship, you think function, and that basically means an equation can be written to go through all points. That's what a functional relationship is. So like just any equation of a line or a parabola would be considered a functional relationship. Okay? So it's basically a direct relationship. A statistical relationship, all right, means that there is no direct relationship. Let me change font here. So there's no direct relationship. Okay. But the data points when plotted when they're plotted may indicate a tendency to be close. Okay. I should say close to some line or curve. That's where a statistical relationship comes in. So that's where I was talking about. You might not include all the points, but you could definitely include some of the points and almost draw a line through some of them. That's what a statistical relationship is about. Okay? Now, types of correlation, I mentioned this briefly. There's qualitative, and quantitative. Okay. Qualitative is looking at things like linear, nonlinear. Basically what we just did on the warm-up. Strong, moderate, weak. Okay, and then positive, negative. That's what qualitative's all about. Okay. Quantitative is putting math into it. Putting numbers behind the strength of correlation. And that's kind of what we're going to be doing the next for this next chapter. We're going to start looking at how do we identify strength of correlation, and then what's that information telling us about the data? Is it strongly correlated? Is it not strongly correlated? And the last thing I wanted to mention was just there is a difference between correlation and causation, which we talked about. Like I showed you that website, Spurious Correlations, where it's like the number of people that drowned in a pool correlated with the number of Nicolas Cage movies released. Like clearly there's not, one of them is not a cause of the other. Okay, but it is important to keep that in mind, that correlation and causation they could relate. Okay, so I guess a good way to put it is what is it? Correlation does not specifically cause causation. if I can spell correctly, specifically. Okay. So just because they're correlated doesn't mean they're related to each other. Basically what I'm trying to say there. Okay. So then the first example today just says, state whether the following statements are true or false. And it's like, the first one's kind of weird because like the IB grades achieved by a student are an effect of their predicted grade given by their teachers. So I don't know if you guys are aware of this, but when we do IB testing and stuff like that, I have to give what I call a predicted grade to the IB board. And then we find out what your actual grade is from the IB exam and stuff like that. So I predict like, hey, I think this guy's been a rock star. He's gonna get a 7 on the IB exam. And then he gets like a 4 on the IB exam. So do you think my prediction has any real effect on your actual grade? Probably not, unfortunately. I wish it did, but unfortunately it doesn't. Okay, but that's IB grades achieved by a student. Okay, and then go ahead and look at the other 3 and decide what you guys think. Height of a person, number of ice cream cones sold, and smoking is a cause of lung cancer. What about part C? The number of ice cream cones sold is a cause of higher temperatures.
False.
False? Why did you say false?
Because the number of ice creams you buy don't determine the weather.
Exactly, yeah. It doesn't matter how many ice creams I'm buying. It doesn't determine the weather. Exactly. So you could argue the other one a little better, right? If the hotter it is, the more ice cream I'm going to sell. That could be a little bit easier of an argument to make, yeah. Ice cream sales do not determine weather. All right, and the last one, smoking is a cause of lung cancer. True or false? That one, I just love your IB textbook throwing it in just to remind you guys that smoking's still bad for you. Still bad for you. Gosh. All right. Anyway, so that one would just be true. Yeah, there's a lot of research that says smoking is a leading cause of lung cancer. Okay, so that's the last one there. Okay, where are we moving to next? Whoops. Moving on. I zoomed in a little bit there, zoom out again. Okay, so now we have Pearson's product moment correlation coefficient. That is a mouthful. But basically, I'm just going to be calling it like Pearson's or Pearson's coefficient is what I'm really going to be calling it. And here's how we do it. It's where you take this R equals S sub xy over S sub x times S sub y, where S sub xy is the covariance, a measure of how 2 variables vary together, and S sub x and S sub y are the standard deviations of x and y respectively. All right, so that's how you would find this R value is what we're going to call it. Okay, and it shows like this really intimidating thing, says, oh, like S sub y, that's going to be the sum of x and y, where you do the sum of minus the sum of x times the sum of y all over n. So it shows you how to calculate it, by hand. But thankfully, we're in an examinations class, an applications class. We're not in the analysis class. And I've got a little note over here that is just so useful for us. In examinations, you will only be expected to use technology to find the value of R. You do not need to learn these formulae. They are presented here to help you explore how things work. So explore away if you feel like it. I don't feel like it. So, but basically there's something called an R value. R value. And that's what relates to Pearson's. So whenever you hear Pearson, we're going to assign something called an R value to the data. Okay. So what we want to do, I took all of this data right here, the math and biology and stuff. I'll show you how to calculate that in a second. But first, why don't you guys do parts A and B? Go ahead and plot all the data points and then comment on the correlation. So qualitative commenting. So positive or negative, strong, weak, moderate, and linear, nonlinear. That's what I want to hear first. And then we'll do part C together, which we're going to find the Pearson's product moment correlation coefficient for this data. Okay? So first of all, when we're plotting these, basically we just have corresponding X and Y value. So 20, 24 would be our point. Just like any other graph. It's kind of weird now because we're comparing like two completely different things, like mathematics versus biology. And they're test results for the 8 students. Anyway, so any correlation we see between math and biology here, what do you guys think?
Positive, linear, and moderate.
Yeah, okay, positive, linear, moderate. Okay, any other guesses? Does anyone think it's like strong instead of moderate?
I said it was strong just because like
Okay.
it looks like you can draw a line through it and there's only a couple outliers on the side, but I could be wrong.
Okay, sounds good. So strong. Yeah, so I could go with that as well. So it's positive, strong. Okay, possibility. Anyone think it's a weak correlation? Okay, not right now. So right now, yeah, we're saying positive and moderate or strong. So this is where part C comes in handy. Because we are asking ourselves, well, like, wait, is this moderate or strong? And that's what Pearson's is all about. So that's going to help us determine the strength. That's what part C is about. Let's see. I had a little thing for you guys, but I didn't. Let's see. So for Pearson, we're saying the R value is 0.86442675, something weird like that. We'll just round it to 0.864. All right. And we still don't know how strong of a correlation that is, but basically the good rule of thumb is the closer to 1 you are, the stronger the correlation. The closer to -1 you are, the stronger the correlation. All right, it's just that a -1 is showing a negative correlation, a +1 showing a positive correlation. And if you get the number 1 or the number -1, that would actually be a functional relationship. You should be able to create a function to draw a line straight through all of that data if you get a 1 or a -1. Okay, that's what that means. So let's interpret our correlation. All right, that's important, from R value. And we'll do that down here. How can I interpret a correlation from its R value? And we're just going to make a range of things. We're going to say, okay, if the R value is between 0, and we're going to say the absolute value of R, and 0.25. Sorry, I did not make this big enough. That is a very weak correlation. Okay. And that's basically going to look like just a scatter, like a dartboard almost. If you're not very good at darts, that's what it's going to look like all over the place. Okay, and we say the absolute value of R because this corresponds to both the positive and negative values. The closer you are to 0, the weaker the correlation. And then we're going to say, I'm going to do different color just to help with the eyes here. 0.25 less than the absolute value of R to 0.5. That's still considered weak. All right. And then you can guess the next one, 0.5 to 0.75 is moderate. And then the last one, 0.75 is less than or equal to R, less than or equal to 1 is strong. So now we have a definition of weak versus moderate versus strong. And this is where quantitative analysis comes in versus before qualitative, we would just kind of be guessing like, that's moderate to strongish. So for our data, for example, 2, this R value right here is going to answer the question. This is definitely strong because it's 0.864. So that takes the guesswork out of it now. Now we can definitely say, yep, this is a strong correlation. Okay, that's the idea with Pearson's. Okay, you see a positive number, it's a positive correlation. You see a negative number, it's a negative correlation. And now you can determine the strength as well. So we're finally putting a little more, what's the best way to say it? I'm lost for
Exact.
words. What'd you say?
Exact.
Thank you. Yes, we're going to put it a little more exact now. Now it's going to be exact. Thank you.